Dear students, this is CIE ASA level question number 1, May June 2013, statistics paper 2, 7-1 version 1. This is the first question, and this have been receiving a request from many of the students and also from few of the feedbacks I just now received after launching my website. So let me take this opportunity to explain this sum nicely to you. Question number 1 goes this way. Mari wants to choose one student at random from Anthea, Bill and Charlie. She throws 2 fair coins. If both coins show tails, she will choose Anthea. If both coins show head, she will choose Bill. If the coins show one of each, she will choose Charlie. Now, the part 1 is explain why this is not a fair method for choosing the student, right? And this question is carrying 2 marks. And the part number 2 is describe how Mari could use the 2 coins to give a fair method for choosing the student. This is again carrying 2 marks. Now, I need to draw your attention to the few more important points. They need to choose one of the students from either from Anthea, Bill and Charlie. She throws 2 fair coins. Let me highlight this one, underline this, 2 fair coins. If both the coins show tail, right? If both tails, she will choose Anthea. If both are head, she will choose Bill. And if the coins show one of each, she will choose Charlie. One of each meaning first head, second tail, or it could be first tail and second head, either one, right? So part 1, they have already given it to you, explain why this is not a fair method for choosing the student. So this sum can be best explained in a by using the T diagram. So there are given 2 coins, right? So let me draw a T diagram for you, which is already drawn for you. Let me just explain this. This is my first coin and this is my second coin. The first coin, I am just throwing it here. Either you are getting a head or a tail. Because it's a fair coin, so I'm getting 50% probability of getting a head or 50% getting a tail, right? So 50-50 here. And then suppose in the second coin throw again, I'll get head or a tail, right? So again 50-50 here, 50% chances and 50% chances. And what if you are getting that tail here? If you are branching out the tail here, then again 50%, again second throw, getting head or tail, again 50% or 50% here, right? We're getting this. So as you know, if you are traveling in the same branch of the tree, before I explain this, if the T diagram concept is not clear to any one of the students, please send a request to by using my YouTube channels or something, so I can record a separate class on how to draw the T diagram nicely to you. Meanwhile, I assume that you people know. So when you are traveling in the same branch of the tree, right? Suppose I'm traveling it here, right? All the way here. So I'm multiplying the probabilities together. So when I'm traveling, this is my head and this is my head. So probability of getting the first head and first head, right? Both the heads here. So 0.5 here, I'm 0.5 here, 0.5 here. Multiplying it together, that gives 0.25. So I indicated here, right? So 0.25 here. So if both the heads, then choose Bill here. If they say here both the tails, then choose Anthea. and tail, both the tails, if I'm traveling this branch of the tree here, I'm getting both the tail here, right? Both here, for example, this probability of tail and tail here, right? Because this is my tail and this is my tail. So again, this is point 0.5, which is 0.25 here. So you're choosing an anthea here. If both the show heads here, then you're choosing the bill here, right? Choosing the bill here if both the heads, right? And if one of them is a head or a tail, one of them, so I need to branch this way out, this way, right? It'll give me head and tail here, 0.5 here. Again, it will give me 0.25, which is already mentioned it here for you. And again, when you can come from this direction also, and so the tail and head here again is a 0.5. Again, this is 0.25. So again, 0.25. The first one could be head and second one could be tail, and or the first one can be tail or second one can be head. So this is the AND condition, or sorry, this is my OR condition, or you are adding it all together, right? So head or head tail or tail or head. So 0.25, 0.25. When you add it all together, that gives me 0.50 here. So the Charlie, if one of each meaning the first one could be head or tail, or I can choose Charlie, or if the first one is tail and second one is head, again I can choose Charlie. So this is, I'm adding it all together. And from the tree diagram itself, you can see this is not a fair method. Why I say this way? Because you can clearly see the chances of choosing Charlie is always 50% here. Let me pick a different colored, maybe black this time. Okay, Charlie here, right? Charlie is all the time is 50% here, one of each. And you can see the probability of choosing the bill is only 25% here, and the probability of choosing the anthea is again 25% here for the anthea. So obviously this is not a fair method. So all the time, most of the time I'll be choosing the Charlie. So explain why this is not a fair method for choosing the student. So for writing the script, I already written for you this way. Okay, so part number 1, this is not a fair method for choosing the student, because the probability of choosing Charlie is more 50%, and the probability of choosing Bill or Anthea is only 25% or 0.25, and hence this is not a fair method. Now second question, what would be my fair method? Fair method would be what? If both the tails, then choose anthea, right? Both the tails, choose anthea, 0.25. If both the heads, then choose bill. Again, this is 0.25. Again, first one is head and second one is tail. Only choose one of the condition, then choose Charlie is again 0.25. Or you can go up and see, and you can choose, you can make your own choices. If you are traveling on the only one branch of the tree and don't add it all together, right? If you choose any one branch of the tree, for example, it's all up to you, you're the boss here, right? So suppose I'm traveling only head here, right? So this again 0.25. Whenever you are getting 0.25 here, say for example you are getting 0.25 here, and again see 0.25, this is 0.25 or 25%. So you can say I am choosing the bill. Okay, and again you can say head and the tail here, head on the tail here, only 0.25. Don't add this part, don't add this part here. Only the first one is head and the second one is tail, again 0.25. Then you choose Charlie. That will be the fair method, right? And then, or you can allow, probability of choosing tail and tail, again 0.25. Tail and tail, again I'm traveling only in this branch, right? So 0.25. Either way, right? Or I can say if both the heads, then choose Charlie, right? It's all up to you, right? And if the head and the tail, then first head and the second is tail, then choose Anthea, right? And third one, when I'm choosing first is tail and second is head, then choose maybe the third students, they say Bill, right? Whatever. So I have given another option here, second fair method. You can have 2-3 fair methods. All is up to you, or that way. So probability of choosing both the heads is choose 25%, and HT first is head and the second is tail, again 25%, again choose bell, again third one is tail, right? First tail, second tail, point 25% Charlie, and vice versa. Meaning you can have any combination of what you call any branch of the tree, as long as the probability of choosing all the three students are equal. Try to pay attention here. Probability of choosing all the three students should be equal, not unequal, the way it was explained in the beginning, right? And hope this is making sense and making clear to you, and hope you have understood this very well. And if you had truly liked it, please go ahead and give a thumbs up, so that you are encouraging me to record more and more videos for you in the future. Thank you. Have a good one. Bye.